In last lecture, we have seen what we have seen in last lecture. Can you just remind me the last topic?
Examples of Fourier transform.
Was it Fourier integral theorem? Fourier integral formula, double integration, omega and s. Then we have seen Fourier sine integral and Fourier cosine integral. So today's topic is Fourier transform. So give the heading Fourier transform. Or you can also call it as complex Fourier transform. Fourier transform or complex Fourier transform. So in that you can write if a function f of x is defined, if a function f of x is defined in minus infinity to infinity, in the interval minus infinity to infinity, is piecewise continuous. So if it is not the continuous on whole interval, it can be the piecewise continuous, like minus infinity to 0 somewhere, then 0 to infinity, continuous in this and in this, there with one discontinuity. It is called piecewise continuous. In pieces, continuous in pieces. Okay, so piecewise continuous in each finite interval. In each finite interval, and is absolutely integrable, and is absolutely integrable in minus infinity to infinity. Then the integral 1 upon root 2 pi inside root 2 and pi, integration minus infinity to infinity f of x into e raised to isx dx is called Fourier transform of f of x, is called Fourier transform of f of x, and is denoted by Fourier capital F transform of f of x, or generally we denote it as f of s, because if we'll solve this, everything will get converted into the variable s, domain change, and we generally denote it as f of s. So thus we'll write now definition. Thus f of s is equal to 1 upon root 2 pi integration from minus infinity to infinity f of x e raised to isx dx is the Fourier transform of f of x. Definition. Write it properly. Single integration now, and we have to solve the integrations. As Fourier integral, there was only the double integration, and whole Fourier transform will be of single integration now. Done writing?
Yes.
Sure. Write down the question. Find the Fourier transform of. Find the Fourier transform of f of x is equal to 1 upon 2 epsilon, where mod x is less than equal epsilon, and 0 when mod x is greater than epsilon. Okay, function is given to you and you have to find its Fourier transform. You will read the question very carefully, properly, as it is Fourier series, or it is Fourier transform, or it is Fourier integral. If it is Fourier, is it half range? Is it full range? Is it sine? Is it cosine? You will read it very carefully. So what is this? This is the Fourier transform. Okay, so we know what is the Fourier transform. So the Fourier transform is, can you just define Fourier transform? F of s is equal to
1 upon root 2 pi
1 upon root 2 pi
integration
integration,
from minus infinity to infinity
right?
f of x
F of x
e raised to isx
I s x
dx.
dx, right? So this is dx. So these are the limits of what? S or x?
X.
X. As it is with respect to x, so these are the limits of x, remember. Chalo. So now we have the function. We have to substitute here the function value. And function is given here, which is break. So how is this interval? Mod x is less equal epsilon means what? You know this. What it means? What is this? Mod x is less than a means?
Minus infinity to a.
Minus a to a. X lies in minus a to a. Mod x is less than a means x range is in minus a to a. So here mod x is less equal epsilon means minus epsilon is less equal x is less equal epsilon. Is that correct? If it is less equal here. Okay, so this is the given interval and this is mod x is greater than epsilon. So when your x is greater than epsilon, you can use mod if you want. So, but the value is 0 everywhere. So no need to think for this function. You only will think of this where x is from minus infinity to infinity. So how the integration limits are now? X is from minus, sorry, epsilon. Am I saying infinity? Sorry. So yes, it is minus epsilon to epsilon. The function is what? 1 upon 2 epsilon into e raised to isx dx. Just we are writing the function over the interval minus epsilon. Okay, but what about this epsilon? Is it the variable or constant?
Constant.
Constant. Epsilon is always a constant number. So epsilon is very small number, you know that. So epsilon and 2 will come out of the integration. 1 upon root 2 pi, 1 upon 2 epsilon, and into integration, we'll write this as it is. What is the integration of E but? What is the integration of E?
E raised to isx upon is.
Very good. Integration of E is E itself upon derivative of this term with respect to X, and the derivative is is. So it is 1 upon root 2 pi into 1 upon 2 epsilon, and integration is e raised to isx upon is. This is from minus epsilon to epsilon. That is 1 upon root 2 pi, 1 upon 2 epsilon. Now the limits will be for what? This epsilon will be for x, as integration is with respect to x. So x first is replaced by upper limit upon is minus lower limit, which is minus epsilon. So minus epsilon upon is. Okay, this is your answer for your transform. Or if it is something like, we have one more formula. What I'll do here is I'll take that is base is the same, 1 upon root 2 pi, 1 upon 2 epsilon, e raised to is epsilon minus e raised to minus is epsilon upon is. Right? But I have the formula where if there is 2I, so what I'm doing is this 2 I have taken out, and this yes I'll take outside. So here epsilon is 2 inside, s outside, without changing the meaning. Okay, but this is nothing but, do you know this formula? E raised to I theta minus e raised to minus I theta upon 2i. What is that?
Sin
Sin theta. Hyperbolic is just 2. If there is I, it is sin theta. If i's are there, it is sin theta. And what is sin hyperbolic theta? E raised to simple theta minus e raised to minus theta upon 2. If there are i's more, this I. So this is sin theta. So this is what then?
sinus epsilon.
Correct. 1 upon this is as it is. E raised to I theta minus e raised to minus I theta upon 2i. Theta is your S epsilon. So theta is your S epsilon. So it is sine of S epsilon. So your answer is finally 1 upon root 2 pi sine S epsilon upon S epsilon. Done.
No, 2 epsilon.
Sorry. 2. Any problem?
In denominator, 2 epsilon instead of s epsilon.
Two. We are already have taken out, taken in. This 2 is in and S is out. S नाही ठेवला इकडे. फॉर्म्युल्यासाठी 2i हवा होता ना, सो 2 आतमध्ये घेतला आपण आणि S बाहेर काढलाय. चेक वन्स. इथे तुमचा IS आहे, जस्ट लिसन टू दिस. इथे 2 एप्सिलॉन आहे आणि इथे IS आहे, पण फॉर्म्युल्यासाठी 2i हवाय म्हणून मी हा 2 इकडे घेते आणि हा S बाहेर घेते. मल्टिप्लायज आहेत ना, सो 2i इथे येईल आणि S एप्सिलॉन इथे येईल आणि 2i इकडे आला की हा होईल फॉर्म्युला साइनचा. ओके,
Yes, ma'am.
राईट. यू कॅन इथे एक आणखी एक स्टेप वाढवा मग. 1 upon root 2 pi 1 upon S epsilon e raised to isx minus e raised to minus isx upon 2i. Is there any doubt? Please ask if you have. There can be directly in MCQ. The Fourier transform of the given function is. So yes, this is the required Fourier transform. Remember the formula important. Chalo, we'll go to next question. Write the question. Find the Fourier transform of f of x is equal to 1 plus x upon a minus a to 0, 1 minus x upon a, 0 to a, and 0 otherwise. If you see, these functions are defined like this in Fourier series also. So it's very important that you read it very carefully whether it is series or transform. And yes, as it is transform, the Fourier transform is. Write the definition first. F of S. So where what we do in Fourier transform is again a transformer where we convert x to S. Can you just check? Your answer previously, everything is in S. There is no x remained finally. Epsilon are the constant, these are constant, and it is a function of S. Right? So what the transformers do, they just transform one domain to other. And here Fourier transform also transforms x to S. That is, here we can call it as a domain which is in X is transformed to S. So you will always check whether everything going into S or not. Variables change or not. Chalo, what is the formula? 1 upon root 2
Root
pi
2 pi
integration
from minus infinity to infinity.
f of x
E raised to isx dx.
e raised to isx dx. Right. So write the function, but function is defined on this interval and this interval. Means integration will
Break.
break. How will it break? Minus a to 0,
And
0
0
to a, right, plus 0 to a, and everywhere else the value is 0. So don't think about the other intervals. On other it is 0 directly. So in minus a to 0, f of x is this. So we are writing f of x into e raised to isx dx as it is. In 0 to a, function is 1 minus x upon a into e raised to isx dx. There are two different integrations. We have to solve them with respect to x. So how will you solve?
Lebanese rule.
Can we apply Lebanese rule?
Yes.
Yes, everyone is getting? Can we apply Lebanese rule here? Can you just think? For Lebanese rule, derivative of one of the functions should be 0. And whose derivative is getting 0 in this?
1 plus minus x.
Right. This whole term is getting derivative 0 after some time. So this is what?
U.
U, right. And this is
V.
V. Same here. This is U and this is V. So we are applying Leibniz. 1 upon root 2 pi correctly है का बराबर में
Yes.
माइनस नहीं ना प्लस है ना सगळं सॉरी it
Plus.
is plus right बाकी functions correct लिहिलेत मी
Yes.
okay
Yes.
so yes this is u, this is v, this is u, this is v. Okay, so we'll apply 1 upon root 2 pi u as it is 1 plus x by a. U into v1, what is integration of this?
E raised to is x upon s.
E raised to the integration e raised to upon derivative of this term with respect to x, derivative is is. Then minus sign u v1 minus u dash, derivative of this, derivative of 1 is 0 and derivative of this term is
1 by a.
1 by a. Derivative of x is 1 and the constant multiplier is there 1 by a. And into integration of this term, what is integration again? E
E
raised
raised
to
to isx upon I square s square.
right upon is into is, I square s square. Right. And what will be the next derivative?
0.
0. Correct. So this is over for the first and this is from minus a to 0. Now second plus 1 minus u into v1 e raised to isx upon is u v1 minus u dash, derivative of this term. What is the derivative? Once a 0 and derivative of this is
Minus 1 by a.
minus 1 by a into integration of this e raised to isx upon I square s square. And next derivative of this will be 0. So this is over from 0 to a. Sure, we'll put the upper lower limits now. 1 upon root 2 pi as it is out. If it is upper limit 0, so x is 0. So 0 upon this is 0. So 1 into e raised to 0. 1 upon is. 1 into 1 upon is. So just 1 upon is. Check once. This is 0. So 0. E raised to 0 is 1. So it is 1 into right. Now, if it is 0 here, e raised to 0, 1 upon, so minus is there, 1 upon a into s square into I square. What is I square but?
-1.
Minus 1. Please remember the value of I square is minus 1. Okay, upper limit minus lower limit. Lower limit you are writing minus a. If you write minus a here, a will get cancelled and there will be minus 1. 1 minus 1?
0.
So 0 into anything?
0.
If we'll put minus a here, that will be there. So it is minus 1 upon a e raised to, you are writing minus a, so minus isa upon I square, that is minus 1 into s square. Okay, this upper lower is done. Plus. Upper limit you are writing a now. So if it is a here, a cancel, 1 minus 1, 0. 0 into anything? 0, right. Write a here. So minus minus is already plus. 1 upon a e raised to isa upon I square. I square is minus 1 into s square. Upper limit done. Minus lower limit you are writing 0 for x. So if it is 0, 0. If it is 0, 1. So 1 into 1 upon, right, 1 upon is. Minus minus plus. E raised to 0, 1 upon a s square. I square is minus 1. So we'll now just open it and see what are the terms. It is equal to, Fourier transform is equal to 1 upon root 2 pi. Just check the terms and tell me. First is 1 upon is, minus minus becomes plus, plus 1 upon a square. Next term, minus, this is 0, minus minus plus, but one more minus here, so minus e raised to minus isa upon a square. Then plus, plus and minus, so minus e raised to isa upon a square. A square ना, लास्टला पण a होताच, इथे पण a आहे, हा वरती पण a आहे, right, a. Next term is minus, plus is out, plus minus minus, and here it is also minus minus plus. 1 plus minus minus 1 is, चलो पहले लिहा minus 1 upon is. पुढची टर्म काय? Minus minus is plus, outside is plus, so plus 1 upon a square. करेक्ट लिहिलं का बघा बरं सगळं. So your plus minus get cancelled.
Ma'am, for that fourth term, plus sign should be there, no?
Plus ekam, just check. Fourth term. 1, 2, 3. Okay, this. Here is one negative sign, beta. Minus 1. Minus,
Yes.
plus minus is minus. Okay, so correct. Chalo, we'll write the next answer then. 1 upon root 2 pi. This and this will get added. 1 plus 1, 2 upon a square. And here, minus 1 upon a square is common. We'll take it out. I'll write this first. E raised to isa plus e raised to minus isa. Check. Minus 1 upon a square from both of the terms are taken out. Then this plus and this plus. E raised to isa plus e raised to minus isa. Right. But this is some formula if there is divided by, what term is there?
2.
2i. If it is I, there should be 2i or 2. No, 2 I guess. cos x
2.
and sin x. What is sin x? E raised to I s x. I told you e raised to I x minus e raised to minus I x upon 2i. And what about cos x? E raised to I x plus e raised to minus I x upon 2 only, not 2i. Sin needs I, cos doesn't need I. So only 2. There is plus here and there is minus. So cos needs just 2. And sin needs I also. Remember. So what should be here? There should be 2. As it is plus, it will go into cos and cos will need 2. So I have divided by 2 means I should multiply by 2 also to this term. So your answer is then 1 upon root 2 pi 2 upon a square minus 2 upon a square into what?
Cos SA.
Cos SA, correct. E raised to I x is cos x, x is a SA. Once again, 2 upon the term is common, you'll take it out. So 2 upon a square into, here it is 1 minus cos SA. Done, the answer. Required Fourier transform. You can also write this 2 as root 2 into root 2. 1 root 2 will get cancelled. And the answer can also be root 2 by pi. 1 upon a square. 1 minus cos ax, cos as. Because 2 we can write as root 2 into root 2. So 1 root 2 will get cancelled. There will be root 2 upon root pi, that is root 2 by pi. So both the answers are okay. Ask for any doubt if you have. No doubts? Chalo,
No.
write the question next. Find the Fourier transform of. Find the Fourier transform. You all are solving with me now. Fourier transform of f of x is equal to 1 minus mod x if mod x is less than 1 and 0 if mod x is greater than 1. We cannot write anything for mod x greater than 1, but mod x less than 1 can be written as what?
Minus 1 less than x.
Right. Minus 1 is less than x is less than 1. This is how is the definition. I told you in the first question itself. Let me just show you. Mod x is less than something. Mod x is less than this means minus a is less than x is less than a. If it is less equal also. Right? So this is not provided. We can write that according to our definition. Means everywhere else the value of the function is 0 and the only where your function is defined is minus 1 to 1. Right? Chalo, we'll solve it. So the Fourier transform is f of s is 1 upon root 2 pi integration minus infinity to infinity f of x e raised to isx dx. But can you just tell me if such interval comes, what just first comes to our mind? Minus 1 to 1 or minus 2 to 2 or minus a to a. If these intervals comes, the very first thing is integration is minus 1 to 1. So what should first struck to your mind?
Even or we can check.
Very good. Whenever integration is minus a to a, if we can check the even odd of this function, the value can directly be 0 if your function is odd, and it can be solved as 2 times 0 to a if the function is even. Right? So job will be reduced if you want. Or if you can directly integrate, no doubt. First question was like that. You can check. where function was so easier that we can directly integrate, only this integration was there. But if the function is harder, you cannot integrate it directly. Can we integrate mod x directly?
No.
No, we
No.
have to write it as the formula. Do you know the formula of mod x? Remember, mod x is x in and minus x in, minus x in and plus x in. All the negatives, if you write negative here, it will become positive. So minus infinity to 0 and 0 to infinity, it is plus x. This is the definition of mod x. Please remember, I told you. Okay, chalo. So we'll write the Fourier transform here. 1 upon root 2 pi integration from, yes, can you tell me? Integration is from, see our function given. Function is defined here, mod x is less than 1. And where it is greater than 1, the value is directly 0. No need to write this. We are writing this. What is this interval? This interval is minus 1 to 1. Is it minus 1 to 1?
Yes.
Right. So integration is from minus 1 to 1. F of x there is 1 minus mod x into e raised to isx dx. But what about this function? 1 minus mod x? Is it even or odd? If we'll change x by minus x, will there be any sign change or something?
No.
No.
No. This is even or odd?
Even.
Even.
Right? But we cannot say about this now, so we can just open it. We have one more formula, e raised to I theta. What is that? Cos theta plus
I
sin theta. This is the formula. So I'll just open it. It is 1 upon root 2 pi integration minus 1 to 1, 1 minus mod x into e raised to isx, which I'll write cos what? E raised to I theta. Theta is sx. So cos sx, right, plus I sin
sin sx.
sx dx. Okay, so this into this plus this into this will get separate. So I'll separate the integration. Minus 1 to 1. 1 minus mod x into cos sx dx plus 1 upon root 2 pi integration minus 1 to 1. 1 minus mod x into I sin sx dx. This into this plus this into this, just separated. 1 upon root 2 pi is for both. Now you told me this is even function. What about cos? Even or odd?
Even.
Cos is always even. Cos of minus theta is cos theta. So if you replace x by minus x, that will be cos sx again. And even into even?
Even.
Even.
So your whole function is even. We'll check about this. This is even, mod. What about sine?
Odd.
Odd.
Odd. Sine of minus theta is minus sine. And even into odd is?
Odd.
Odd. So what about this integration? What will be the value?
0.
Directly the answer is 0. So we need to just solve this integration. And as it is even, what you can write? Minus 1 to 1 can be written as? You forgot the formula?
2 times 0 to 1.
Right. Integration minus a to a f of x dx is 2 times 0 to a f of x dx if it is even function, and is directly 0 if it is odd function. So it is directly 0. We have written the value as it is odd. And as it is even, you are writing 2 times 0 to a. Upper limit is 1. So 2 times 0 to 1. 1 minus mod x into cos sx dx. But now x is defined in 0 to 1. Means which interval? The positive interval. So all the values are positive. So can I write mod x now x?
Yes.
Right. Now we can remove the mod because it is from 0 to 1. That is all the positive numbers are there. Here we cannot remove mod as it is minus, negative numbers are also there. So here we are not able to remove. But once we can write 2 times all the positive, so we can remove the mod. And once the mod is removed, we can integrate this. What is this integration? How will you solve the integration?
Lebanese rule.
Lebanese rule. This is U, this is V. Right. So U into V1, integration of cos. What is the integration of cos?
Sine.
Plus sign or minus sign?
Plus sign.
Plus
Plus
sign.
sign. Derivative is minus. Correct. Sin Sx upon what? S or X?
S.
S. Right. Because it is with respect to X. So derivative of this with respect to X. That is the constant is S upon S. Minus derivative of this.
-1.
Right. Minus 1. 1s are 0. Minus X is minus 1 into integration of this.
Minus.
-6.
Minus of cos. Integration of sine is minus cos Sx upon
Yeah.
S, already 1s. So S into S, S square. And derivative of this next will be 0.
0.
And this is done. 0 to 1. Just put the upper lower limits. You are there. If the upper limit is 1, so 1 minus 1,
0.
0. 0 into anything, 0. So 2 upon root 2 pi. 2 upon root 2 pi into upper limit you are writing, which is 0. Here you are writing 0. So cos 0. What is the value?
1.
1. 3 negatives means minus 1 upon S square. Minus 1 upon S square. Then negative sign and lower limit, which is 0. So if x is 0, sine 0.
0.
0 into anything.
0.
So it is 0 here. And if it is 0 here, cos 0, 1. 1 upon S square. 3 negative, so minus 1 upon S square. Correct, Eka? Okay, so it is 2. You can write root 2 into root 2 if you want. So root 2, 1 root 2 cancel. So here root 2 into root pi, you can write 1 root 2 cancel. So it is root 2 by root pi or root 2 by pi. Minus 1 by S square plus 1 by S square. What happened?
Ma'am, when we put upper limit x equal to 1, then there is cos s upon s square.
Just a minute, let me check. Yes, we are writing here. X is 1, so cos S is there, right? Cos
Yes.
S upon S square. For the upper limit, if X is 1, cos S upon S square minus cos S upon S square, I'm sorry. So here it is cos S. Cos S upon S square. Now it is correct. So it is cos S upon S square plus 1 upon S square. So here 1 upon S square is common. We can take it out. Into there is 1. And here it is minus cos S. Done. The answer. So if the function is like a mod something into there is other function. So you cannot integrate directly. Just check for even or. If it is minus 2 plus something, just try to write whatever you know. If it is even, write 2 times. If it is odd, directly you will write the answer 0. And if it is easier, like the first epsilon or constant, you can just integrate directly. Do this. Find the Fourier transform. Find the Fourier transform of f of x is equal to e raised to minus mod x. Chalo, do it. Tell me the answer. Write the formula first. F of s is equal to 1 upon root 2 pi minus infinity to infinity f of x e raised to isx dx. Okay, given is the function. So we have the function, but limits are not given for the x. So what are the limits of x here?
Minus infinity to infinity.
Very good. If not given, we are not going to change this. If it is defined particularly, you just change. But if it is not, let it as it is. Minus infinity to infinity. So it is 1 upon root 2 pi minus infinity to infinity. F of x is minus mod x e raised to into e raised to isx dx. Right, minus infinity to infinity. So you can just check this function whether it will be even or odd.
Even.
Even, because if we'll change x by minus x, there will be the no change in sign of the function, or there will be no change in function itself. So function remains as, means it is even. Yes, because we are checking it because there is more x and we are not able to solve it directly. So you should always check this, right? As we know, this is even, but we cannot talk about this right now. So we just write it as, how can we write this? For even or, this is, we know even, but this e raised to minus, so we cannot here check even or. So for this e raised to isx, what you are going to write?
Cos sx plus I sin sx.
Correct. So minus infinity to infinity, e raised to minus mod x, e raised to I theta cos theta plus I sin theta. Theta is sx dx. Right. So just separate 1 upon root 2 pi minus infinity to infinity e raised to minus mod x cos sx dx plus 1 upon root 2 pi integration e raised to minus mod x into I we can take out into sin sx dx. How is this? You told me just now? Even.
Even.
How is cos?
Even.
Even. Even into even?
Even.
So this is even function. Okay, this is even, sine is odd. Even into odd is odd. And as it is odd, the answer of this whole is
0.
0. No need to solve, it is directly 0. We are solving this. But as even, what you can write for this integration?
2 times 0 to infinity.
Integration 0 to infinity.
Correct. So it is f of s is equal to 1 upon root 2 pi 2 times 0 to infinity e raised to minus mod x into cos sx dx. Have I written it correctly? Yes. बाकी आगे का तो 0 है. As it is odd, it is directly 0. But as we are defining this from 0 to infinity, what you can do?
E raised to x.
Right? E raised to, that mod we can remove now. E raised to minus is there and mod we can remove and write x only. We cannot change this sign. If it is Inside we can think, but outside as it is, and mod can be written as x only from 0 to infinity into cos sx dx. This 2 you can write root 2 into root 2, and this root 2 into root pi denominator. So root 2 get cancelled. It is root 2 by pi. And we have to solve this integration. Think and tell me, how do we solve? Oh, wait, can we apply the Lebanese rule here?
No.
No.
No. The reason?
Both the functions are integrable.
Yes, both are integrable, but neither of the functions derivative is
0.
0. एकाचंही डेरिव्हेटिव्ह 0 होणार नाही. ईचं डेरिव्हेटिव्ह ईच राहते, कॉसचं साइन, साइनचं कॉस, cos sin, sin cos, right? So it is not getting 0. Right. So in such cases, we have one formula. E raised to ax into cos bx dx. Two formula there. For one is for cos and other is for sin. So what is this? E raised to ax cos bx?
E raised to x upon a square plus b square
Correct.
into a cos bx plus b sin bx.
Very good. A cos bx plus b sin bx. A into whatever sin. If sin, write a into sin. A into cos, write cos. And whenever it is cos, there is plus in between. If it is sin, there is minus in between. A becomes b, cos becomes sin. So you are applying this formula here. So can you just tell me what is your A here? If you
Minus 1.
compare, right? Minus 1. And what is B here?
X.
S or X?
S.
See it carefully. S or X?
S.
S. आता हे पुढे चेंज होणार आहे. आपल्याला इनव्हर्स फुरियर ट्रान्सफॉर्म जेव्हा करायचंय तेव्हा इथे एस होणार आहे. हे असंच राहणार आहे, इकडे एस होणार आहे. तेव्हा तुम्हाला बी ओळखावं लागेल. तिथे पुन्हा एकदा विचारेल मी. तर इथे एस असेल तर काय असेल? डी एस जर असेल तर काय असेल तुमचा बी?
X.
एक्स असेल. कॉस एस एक्स डी एस जर झाला तर हा झाला कॉस एक्स एस डी एस. एक्स एक्स एस एस. सो यू विल राईट बी इज एक्स. हे उलट पण होणार आहे, इनवर्स. Okay, chalo. A we have, B we have, we'll put in the formula. So it is e raised to the whatever term is as it is, e raised to minus x upon a square minus 1 square plus b square s square into a is minus 1 into cos sx minus a into a is minus 1 into cos sx plus b is s plus s into cos will become sin sx. And this is from 0 to infinity. So if you put the upper limit infinity, what will be the value?
0.
As it is. Very good. If we put infinity, we are writing x as infinity. So it is e raised to minus infinity. E raised to minus infinity, 1 upon e raised to infinity. Something raised to infinity, infinity. 1 upon infinity is 0. Right. So this is 0 upon anything 0, 0 into anything, the whole term is 0. If it is upper limit infinity. Minus lower limit is 0. So x you are writing 0. E raised to 0,
1.
1 upon minus 1 square is 1 plus s square into cos
Minus
0. So cos 0 is
1.
1. So minus 1 and sin 0 is
0.
so 0 here. Sin 0, 0, 0 into anything 0. So write the final answer. This is minus and this is minus plus. So plus 1 upon 1 plus s square. 1 upon 1 plus s square. This is your required Fourier transform. Can I write it here only? It is answer later. Okay, so your answer finally is f of s is equal to root 2 by pi 1 upon 1 plus s square. Done. Is the Fourier transform clear to you now?
Yes.
Right. Write some homeworks then and try them. Find the Fourier transform of. Find the Fourier transform of two questions you'll write. So write the first, f of x is equal to k when mod x is less than a and 0 when mod x is greater than a. And one more. Second, f of x is equal to x square when mod x is less than a and 0 when mod x is greater than a. We'll write one more. F of x is equal to 1 and 0. 1 if a to b and 0 when x is less than a and x is greater than b. Otherwise, only defined in a to b. The value is 1. Okay, these are the homeworks. If you have now any doubt, please ask, or else let me take the attendance. Please wait, do not leave. Yes, done. Sure. Can we stop?
Yes.
Yes.
Bye.